we can leave everything uninitialized. It seems like that something has to be initialized, because otherwise, if I access a bracket I minus 1, am I not going to access something that is uninitialized, and we cannot add a unknown value to an unknown value. So we'll see why this is actually okay in this case. Line 1, in this case, initializes I to 1 instead of 0, and that's important in this example. Line 2 is initializing a bracket 0 to 1. So in this case, it is very, very clear that we want to access column D and put a value of 1 in it. Are we okay so far? Okay, because a bracket 0 is a very clear-cut case. We use 0 as the index to access an element in an array. Then we go to line 3. Line 3 is asking the usual question. You will see that almost every array-based algorithm, almost, not every, has the condition like this. I is less than bar a bar, because when I does get to bar a bar, then I is no longer a valid index into the array. So that's why it has a boundary like that. Is that true or is it false? It is true, because bar a bar is 3 and I is 1 at this point. The condition is true. We go to line 4. So here is the big question. What does line 4 do? It seems kind of odd and strange. Whenever something looks really odd and strange, you have to fall back to the fundamental concept. In other words, we look at this statement, we look at line 5, and we ask, what type of statement are we dealing with here? The arrow tells you it is an assignment statement. Okay? What do we do with an assignment statement? We evaluate. Go ahead.
Evaluate the right hand. Your state value of the left hand side is the value of the right.
So the order of operation is to evaluate the right hand side first. Whatever value it is, we will use it to update whatever is specified on the left hand side. Okay? So that tells you that we have to evaluate this part of the expression first. We have to evaluate this little expression here, right? Because it is the right-hand side of the assignment statement. Well, with this one, we can tell that this is an addition operation. An addition operation means you have to evaluate the left-hand side, the right-hand side, and you just add up the two values to become the sum of the entire expression. In other words, I think the bottom line is, do we know what this is saying? Now, when you look at something like this, it is important to remember the -1 or the subtraction of 1 is inside the square brackets, not outside the square brackets, because it makes a huge difference in terms of the meaning of this line, of this code here. In this case, we have to evaluate I minus 1 first, because I minus 1 as an expression is entirely inside the square brackets. Are we okay so far? What is I? Lost the trace part here. I has a value of 1 at this point, right? 1 minus 1 is 0. So that means a bracket I minus 1 is referring to a bracket 0 at this point. Okay? Is a bracket 0 okay? Does it have an unknown value at this point? It has a value. We initialized it before we got into the loop. It has a value of 1. Okay, well, that applies to the other side of the addition as well. So we have 1 plus 1, which is 2. So we have to update the left-hand side with a value of 2. What is the left-hand side specifying? A bracket I, and I is 1 at this point. So that means we're updating a bracket 1 with a value of 2. Very good.
That doesn't make any sense.
Okay, go ahead.
If I is equal to 1, 1 minus 1 is 0.
Yep.
So 0 plus 0 is 0.
But 0 is not used to specify the actual value. 0 is used inside the square brackets, which means 0 in this case is telling me which element of array A do I want to access. Okay, so you got to kind of remember that the number inside the square bracket is not the value that we are interested in. It is specifying where or which element in the array are we trying to access. Are we okay so far? And I think you guys can see how this can cascade. In other words, in the next iteration, a bracket I minus 1 will specify a bracket 1, and therefore we will never access an initialized value, because the previous one is always initialized by the time we get to I equals whatever. Yeah, we'll just go ahead and finish it. Line 5 increments the value of I, so I goes from 1 to 2. Then we go back to line 3 again. We ask the question, is 2 less than 3? Because bar A bar is 3. The answer is true. Yes, it is the case. We go to line 4 again, but this time line 4 does not seem as mysterious because we know how to deal with it last time, and we should be able to deal with it now. On the right-hand side of the assignment statement, we have a bracket I minus 1. I has a value of 2 at this point. I minus 1 is 1. So a bracket I minus 1 close bracket is specifying a bracket 1. A bracket 1 has a value of 2. 2 plus 2 is 4. And where do we put the 4? We put it inside a bracket I. I is once again 2. So a bracket 2 is getting updated to become 4. Then we go to line 5. Line 5 is adding 1 to I. I goes from 2 to 3. We go back to line 3, and then we ask 3 is less than 3 is false. And we are done. In other words, what this little piece of program is doing is it is finding powers of 2. It starts with a bracket 0, which is 2 to the power of 0. Then you look at a bracket 1, it is 2 to the power of 1. You look at a bracket 2, it is 2 to the power of 2. If I had more elements in the array, it would just keep going like that. Each element is twice the value of the previous one. Yep.
Can an array ever have a dead element?
Define what is dead.
One that's never touched, one that never gets a value.
It's possible, one that is uninitialized.
And it could still be a valid algorithm.
It depends on what the algorithm is trying to do. Yep. In some cases, if you have what we call a hash table, in the case of a hash table, the table is supposed to be sparsely populated. In other words, you do have to have a lot of things that are unused in the hash table. But they're still initialized. They're just not containing any useful value. Very good.
So if you were to have a dead branch from an array, that's still program array?
No, an array cannot have a dead branch because a dead branch is a concept that only applies to conditional statements.
But you said that array doesn't have to just have assignment statements. You said it could be, can't we have a conditional statement?
We can have conditional statements that involve arrays.
Oh, but not in the array itself.
Yeah, an array is a way to organize variables.
So we can only assign values to an element in an array.
That is correct. Okay. Well, let's go and take a look at the third algorithm. We have just enough time for one more. And I will call this powers of 2, which is exactly what it does. And now we'll take a look at the third algorithm. Because I think, exposure to kind of known algorithms is going to be helpful. And this one is actually known. We have seen it many, many times. It's just that we have never seen it the way I present it here. Okay, so let's go ahead and take a look at what we're going to do with this one. So I gets 1, okay, just like last time. It skips the first one for a reason. And then we have z gets a bracket 0. Okay, just kind of like the last one, except the direction goes in the opposite direction, because this time we have a bracket 0 on the right-hand side and not the left-hand side. The loop is still the same thing. While I is less than bar a bar, do the following, which kind of implies that we have to go through all the elements in the array. For each element we are seeing, we ask the question, is z less than a bracket I? If that is the case, I want z to get updated to become a bracket I, and if I gets I plus 1, and while. And this is also a perfect time to preach the importance of indentation. Because without indentation, this code is not really that easy to read. I mean, you can read it, but it's not, easy. So it's good. It's always a good idea to use indentation to indicate which statement is containing which other statement. Now it looks a little bit better. We have seen this algorithm already. Can you guys remember where we have seen it? It's the first algorithm that I presented when we talk about arrays. Okay. Now let's go ahead and take a look at a trace of this algorithm. Now this algorithm is going to find the maximum of some number of array elements. So that means I have to give you an initialized array, because otherwise you cannot tell me which one is in fact the maximum. This time we have quite a few more items. We have array A, and once again, let's just say that A has 3 elements. And now we can shrink the columns all at once. Okay, you can still see everything on the screen. Okay, that's good. Okay. So the precondition of this is I have to tell you the initial values of the array, because this algorithm is now trying to find the maximum of 3 variables. I have to tell you the values of the variables before you can actually go find the maximum values. We'll go with 2, 3, 1. Okay, those are the values of the array elements. Okay, line 1 is initializing I to 1. Line 2 is copying the value of A bracket 0, which has a value of 2 to Z. So Z now starts with a value of 2. Then we go to line 3. Line 3 is asking the question, I is less than bar A bar is true, because I is 1, bar A bar is 3. In this case, we have 3 elements in the array. So now we go into the loop. When we get into the loop, the first thing we see is a conditional statement, the first line of a conditional statement, which means we have to evaluate the condition of the conditional statement. And this time we are asking the question, is Z less than A bracket I? Is that true or not? What is I? I is 1 at this point. So A bracket I is referring to A bracket 1. A bracket 1 has a value of 3. What is Z at this point? Z has a value of 2. Is 2 less than 3? 2 is less than 3 is true. Okay? So the condition of the conditional statement is true. We have to go into the conditional statement. Onto line 5. What does line 5 do? Line 5 is going to copy the value of A bracket I to Z. Once again, I has a value of 1 at this point. A bracket I refers to A bracket 1, which has a value of 3. We are copying that value to Z. Z is column D, so now it is updated from 2 to 3. We are done with the conditional part. We're done with the conditional statement, so we are moving on to line 7 at this point. I goes from 1 to 2. We go back to the beginning of the loop at line 3, on line 3. I is 2, 2 is less than 3 is true. Bar A bar is 3. Then we go to line 4 again. Z is less than A bracket I. Is it true or is it false? What is I? I has a value of 2, so A bracket I is A bracket 2. A bracket 2 has a value of 1. And Z has a value of 3. 3 is less than 1 is false. Very good.